Hello everybody, this is Mrs. Pinkerton and welcome to the first topic in AP Chemistry. Today we're going to be learning about moles and molar mass. This is topic 1.1. And make sure you understand this well. This is a foundational topic. If you had chemistry before, this should be review. If not, really take the time to understand this because we use this all year long. And so if you are unsure or uncertain how to do these calculations, make sure you practice because it's foundational to much of the content we learn throughout this course. So the mole is a very large number of particles. A mole has approximately 6.02 times 10 to the 23 particles. Now again, it could be particles, it could be atoms. If I had a mole of shoes, it would be 6.02 times 10 to the 23 shoes. So it's just a number that designates what a mole is. Similar to a dozen. A dozen says you have 12, right? So a mole is 6.02 times 10 to the 23. You do not need to memorize this number, but we use it so much that you likely will know it. If you go and look at the AP formula sheet, you'll see that Avogadro's number, that's what we call it, is on there. So if you forget or you blank out, you can always go to your formula sheet and find that number. Now, the first thing we want to learn about is the molar mass. And the molar mass is the total mass of each substance based on the chemical formula. So you're going to fill in formula there. Now, an example that we can show you is here. We have Ca3PO4 2. And how do we find the molar mass? The molar mass is just the mass of 1 mole of that substance. So we have to look at the periodic table. And again, I'm going to use the AP Chem reference table, which is up here. If you have a different periodic table for now, that's fine. Just know that this is the periodic table you will use on the AP test and see that it only has symbols. It doesn't give you the names, but you will be using it hopefully throughout the year that you'll be familiar with the names and their symbols. So we find the molar mass off the periodic table. And the number that we use is the average mass. So that's these numbers down here, okay? Now remember the numbers above, that's the atomic number. The atomic number tells us the number of protons the atom has, and that identifies the element. So if you change the atomic number, you have a new element. The atomic mass is the average mass of that atom, okay? So we're going to use that number, and you'll see the first thing we have to do is count how many atoms we have of each element in our formula. So here at calcium we have 3. Phosphorus, now remember if it's in parentheses, we have to distribute that 2 and multiply, just like you do in math. So we have 2 phosphorus, and then oxygen, there's 4 within the parentheses, but outside the parentheses we have a 2, so we have to multiply that, so we have 8 total oxygens. Now I need to look to the periodic table to find their mass. And when I do, I'll just show you calcium, for example. We'll see that calcium has a mass here of 40.08, so that's the number I'm going to use. Oxygen has a mass of 16, and phosphorus has a mass of 30.97. So I'm going to take those numbers, I'm going to take their average atomic mass and multiply it by how many of each atom I have. And when you do that, you add it all together. So you're going to multiply them and then add them up. You get 310.18 atomic mass units. That's one way we say it. Or more importantly, the molar mass, which is 310.18 grams per mole. So what does that mean? That means if I were to take 6.02 times 10 to the 23 particles of this compound and weigh it, it would weigh 310.18 grams. So this is grams per mole, per 1 mole, okay? So that's important. And mole, we abbreviate with MOL. I'm not spelling it wrong, but that's a shorthand way that we write moles. So you can leave the E off if you want to write it shorthand. So now it's your turn. See if you can figure out, pause the video, the molar mass for each of these formulas. Okay, so to find the molar mass, I'm going to take each of my elements. I have carbon, I have hydrogen, and I have oxygen. I'm going to find out how many I have of each. Remember, the subscript here tells us how many we have of each, and that there's no parentheses, so we don't have to multiply. So I have 12 carbons, I have 22 hydrogens, and I have 11 oxygens. I'm going to multiply that by the mass on the periodic table. And again, I go up here to find the masses. So carbon is 12.01, oxygen is 16, and hydrogen is 1.008. So I'm going to plug those numbers in, and then I'm going to multiply them. 12.01, 1.008, and 16. So I do that. And if I plug that into my calculator, I get 144.12 and 22.176 and 176. I'm going to add those together, and I get 342.30 grams for every 1 mole. And that's my answer. Now we have sodium chloride down here, and I have one of each, right? So if there's no subscript in chemistry, if there's no number there, we assume it's 1. So we have sodium, we have 1. We have chlorine, we have 1. I find their values on my periodic table. Sodium is over here, 22.99. Chlorine is over here, and it's 35.45. So I'm going to plug those numbers in and add them together. So 22.99 and 35.45. They're multiplied by 1, so it's the same number, and I get 58.4 grams per mole. And again, if you're using a different periodic table, you might have a slightly different number, but that's okay, just as long as you're doing your calculations correctly. So we have a thing called a hydrate, and if you have a hydrate, it's a compound that attracts and absorbs water, and the molar mass includes the water for that hydrate. So here we have an example of iron 3 chloride hexahydrate, and we'll show you how to find the molar mass. We have 1 iron, we have 3 chlorines, and now we have this coefficient here. It's a 6. So the 6 actually, as in math again, we have to distribute that 6 across our molecule. So we multiply. So we have 6 times 2 hydrogens, which gives us 12 hydrogens. And we have 6 times 1 oxygen, which gives us 6 oxygens. And then we look to the periodic table to find their masses. So again, you'd go up here and you would look up all their masses. For example, we have iron here at 55.85. And part of the challenge is just going to be getting familiar with the periodic table and finding these elements. And you're going to find, all the elements on your periodic table. And you're going to multiply the mass by how many of each of the atoms you have. Add it together, and you get 270.30 grams per mole. So that's how you find the molar mass. And again, that's important because we use that as a conversion, that we know the mass of an item, okay? So again, we can use this number to do mole conversions. And once again, if you have had chemistry before, we call this dimensional analysis, you would have done this already. But if this is your first exposure to moles and chemistry, and you're taking AP Chem before taking regular Chem, you really need to practice this and really feel comfortable with these conversions. And again, it's just unit conversions like you did with your metric conversions, or if you're going from feet to, say, meters, you have to use equivalencies, and we do that in chemistry as well. So if you're given the mass of something, or you're given the number of particles or atoms, the first thing we have to do is convert it to a mole, okay? So we have learned so far that the mole is equal to, 1 mole is equal to 6.02 times 10 to the 23 of anything. Let's just say particles or atoms or formula units. We have learned that 1 mole is equal to the molar mass of that chemical formula. And there's one more thing that we'll learn later, that we know that 1 mole is equal to 22.4 liters of a gas. Okay, and you don't have to memorize that either. It's on your formula sheet, and that will come up later. So how can we write this? I can say that 1 mole over 6.02 times 10 to the 23 particles. It's the same thing. Or I can put 6.02 times 10 to the 23 particles over 1 mole. And that is a way that we can convert from one to the other. I can also say that 1 mole is equal to the grams of that chemical formula. Or the grams of that chemical formula that we did before, the molar mass, is equal to 1 mole. Now I'm going to leave out the gas for now because we're going to do that later. But this is important because we're going to use that to cancel out units so that we can convert from grams to moles or moles to particles. But the key is that if you're not given the moles initially, you have to convert to moles first. So you have to go through the mole to do any conversions from mass to particles or particles to mass. You always have to convert it to a mole first. So let's practice that. The first example you're given, it says, what mass of carbon is consumed in the reaction when you have 0.85 moles of carbon? So I'm given moles first. Yay, that's only one step to get to mass, which is grams. So here. So I'm going from moles to mass, so I'm going this direction, and it says I have to multiply it by the molar mass. Well, how do I know that? Well, because my units are going to cancel out. So I always start with what I'm given. So what I'm given always goes on top, and I was given 0.85 moles of carbon. Sometimes I'll put a 1 here as a placeholder just to make sure that I don't write anything in the bottom there. Now this little railroad track, or sometimes we call it a table, these are fractions. So these are like writing fractions next to each other. But we use this table because it's easier to just show how we can cancel units and use what we call dimensional analysis. So I write moles on top. So if I have moles on top, I want to cancel moles out. So I have to put moles on the bottom. And here I know I can go from moles to grams right here, that I know that the grams of my chemical formula is equal to 1 mole. So I'm going to fill that in here. I have 1 mole, and if I look up carbon on my periodic table, which is up here, I know that the mass is 12.01 because I only have 1 of them. It says 1 carbon. So what happens is my moles of carbon cancel out, and I'm left with grams of carbon as my units. So I take anything that's on top and I multiply it and divide by anything that's on the bottom. So I have 0.85 moles times 12.001, and that gives me my answer of 10.21 grams of carbon. Okay? Now what if I want to, instead of finding mass, what if I want to find atoms or particles or formula units? Well, then I have to use Avogadro's number, and that's that 6.02 times 10 to the 23. So here it says how many atoms are consumed in the reaction. So again, if I'm given moles, I'm going to start with the moles. If I'm not given moles, I have to convert to moles first. And I'm going from moles, and I want to know how many atoms there are. So I'm going this way. And it says I have to multiply that by Avogadro's number. Well, how do you know that? Well, I know down here that if I'm starting with moles, I have to put moles in my denominator to have these moles cancel out. And I want atoms on top. And I know here that I have 6.02 times 10 to the 23 particles or atoms or anything for every 1 mole. So I start with what I'm given, which is 0.85, and I put 6.02 times 10 to the 23 atoms over 1 mole. My moles cancel out. I'm left with atoms, and then I multiply it. 0.85 times anything on top, 6.02 times 10 to the 23 atoms divided by 1 on the bottom, gives me 5.12 times 10 to the 23 atoms. Now, here's an important thing. You need to know how to use your scientific calculator. And I can't show you just any calculator because there are very many different versions. There's Texas Instruments, there's Casio, there's just generic calculators. And in my calculator, to put something in scientific notation, I take 0.85 and then I press times, and then I type in the number 6.022 times 10 to the 23, and then I find a button. It says 6.022. Let me start that over again. 0.85 times 6.022, and then I find a button that says EE. That is the times 10, and then I'm going to type in 23. And then my calculator will give me 5.12 times e to the 23. And I need to know that this means times 10 to the 23. So please take the time to look at your calculator. Sometimes the e won't even be there. It'll just do this, and you have to know that it means times 10 to the 23. But there's YouTube videos for all the different types of calculators out there, but please make sure you look to how to use your scientific calculator and make sure that you know how to use it in scientific notation form. Okay? So now I want you to try to convert 4 grams of sucrose into moles and then into molecules. And pause the video and see if you can do it. Okay, so the first thing we want to do is we're going from grams to moles. So I'm starting with grams here, and I want to go to moles. And here it tells me that I divide by the molar mass. Do I have to memorize that? No, because I can use dimensional analysis. I can cancel out my units by using my equivalencies down here, okay? So what I'm going to do is I'm always starting with what I'm given, and I'm going to put it in this little ladder form, actually. So I'm going to put it in this ladder or railroad track or table form. And I'm always starting with what I'm given. I'm given 4 grams of sucrose. I'm not going to write this all out because it won't fit, but usually we write the formula just to keep track of what we're canceling out. And I'm going to put it over 1, so I don't write anything there. Now I want to get rid of grams, so I put grams on the bottom. And do I have anything that goes straight from grams to moles? Well, if I look here, I do. I have grams on the bottom here and moles here. That's my molar mass. So I put for every 1 mole of that sucrose I have, and we actually solved for it up here. This is the same chemical formula. I have 342.30 grams. So I'm going to plug that in, 340.32 grams of sucrose. Now notice My grams cancel out because I have 1 in my numerator, 1 in my denominators, and I'm left with moles, which is the units I want. So now I multiply everything on top and divide by what's on the bottom. So it's 4 divided by 340.32, and I get 0.012 moles of sucrose. Now, why did I round to 0.012? Well, that's my significant figures. I was given 4.0 grams, so that's 2 significant figures when you go back to your review of significant figures. And remember that leading zeros are not significant, but anything after is. So I rounded to 0.12, which is 2 significant figures. Okay. So molecules, how many molecules are sucrose in the packet? So I want to go here to molecules. If I start with mass, I have to go through the mole first and then to molecules. But here I already solved for the moles. So I can go from moles to molecules. And it says I multiply by Avogadro's number. So I'm always going to start with my moles, which I solved for up here, 0.012 moles. That's what I solved for, or what I'm given. I'm going to put that over 1. I want to get rid of moles, so I put moles in my denominator. And when you're converting to moles, it's always just 1 mole. So you're always just going to put 1 there. And then I look to see, for every 1 mole, how many molecules or particles. The numbers, Avogadro's numbers, 6.02. So I'm using this conversion factor. 6.02 times 10 to the 23 molecules. I multiply by everything that's on top and divide by what's on bottom. And again, because I have moles in my numerator and my denominator, those units cancel out. I'm left with molecules. And I get 7.1 times 10 to the 21 molecules of C2 or C12H22O11 or sucrose. Okay. So again, please make sure you know how to use your scientific calculator to plug those in. Now, a lot of times you're going to go straight from grams to molecules. So it's not going to tell you to go from grams to moles and then moles to molecules. It's going to just say how many grams make this many particles. So I'm going to go ahead and do that for you just so you can see how to do a whole length of this. So I'm going to use the same numbers up here. I'm going to start with 4 grams of sucrose, and I'm going to go straight to how many molecules there are. So again, if you have to go from grams to molecules, you have to go through the mole first. So again, we're going to use our dimensional analysis, our little ladder here. And the first thing I do is I always start with what I'm given, which is 4 grams of sucrose. And I'm going to put that over 1. And then I want to get rid of grams. So I know here I'm going to use this equation because I have to convert to moles first. So I have to convert to moles first. Okay. So for 1 mole, 1 always goes there when you're converting to moles. And then remember, we found the molecular mass of sucrose. It was 340.32 grams. So now if I cancel this out, I'm left with how many moles I have, but I don't want moles, I want molecules. So again, I have to put 1 mole down here to get rid of it. And I know that for every 1 mole, I have 6.02 times 10 to the 23 molecules. Okay, and again, we would normally write the chemical formula as well next to it, but just to save space right now, I'm not doing that. So notice now that I'm going to multiply by everything that's on top, 4 times 1 times 6.02 times 10 to the 23, and divide by anything on the bottom. So that's 340.32 grams. You can do it in any order you want. Typically, I ignore the ones and I take 4 and then divide by 340.32 and then multiply to get your answer which is 7.1 times 10 to the 21 molecules. Okay, good luck with that. Make sure you practice. There's other videos that you can watch that I've attached to your review packet, and just practice, practice, practice till you're comfortable with this. Good luck.